Welcome for this lesson. We're going to study two questions in session 1, paper 2. And the first one is on geometric progressions and arithmetic progressions. So the question says that the first, the third, and the ninth term of an increasing AP makes the first three terms of a GP. If the first term of the AP is 3, find the common difference of the AP and the common ratio of the GP. So this one should be the common difference. Find the common difference of the AP and the common ratio of the GP. We are given the first three terms in an AP, but they are made by the first, third, and ninth term of AP. It is very important to remind ourselves how we get the nth term in an AP, and this is given by first term plus n minus 1 multiplied by d, where d is the common difference. Therefore here the first term is going to be a, because first term is always a. Then the third term, according to this formula, is going to be a plus 3 minus 1, we get 2. Then we multiply it with the unknown d. And the other term is ninth. The ninth term is going to be a plus 9 minus 1, then multiplied by the unknown d. So these terms are going to be, because the first term of the AP is already known, this one is going to be 3, this one is going to be 3 plus 2d, and on this side we'll have 3 plus 8d. So now we are told these first, third, and ninth terms in the AP make consecutive terms in a GP, which means if they are in the same GP, then they have a common ratio, in that when we take the second term in that AP now, which is 3 plus 2d, and we divide with the first term, which is 3, we should get the same ratio as we get when we divide 3 plus 8d divided by 3 plus 2d. So now we can solve for d by cross multiplying, and when we cross multiply, we will have 3 plus 2d squared, because we are multiplying with itself on the other side, and that will give us 3 plus 2d times 3 plus 2d. Then 3 will be opening these brackets here on the other side, such that this one becomes 9 plus 12d plus 4d squared equals to 9 plus 24d. Now with this, we can group like terms together, in which case 9 is going to simplify because it is appearing on both sides. We can remain with 4d squared equals to 24d, subtracting 12d will get 12d, such that because d is appearing twice, d can cancel with d, and we have 4d becoming 12, such that d is going to be 3. So the common difference in the arithmetic progression is going to be 3. Now we can replace it in this side, such that we know the first term is 3, the second term is going to be 3 plus 2 times 3, because we've known the value of d, and this term is going to be 9, and this one is going to be 3 plus 8 times 3, which is 18, getting a 21. So the terms are 3, 9, and 21. 3, 9, and 21. Therefore, for us to get the common ratio, we can either get 9 and divide it with 3, or we get 21 and we divide it with 9, and in all cases we're getting a 3. Therefore, the common ratio in the geometric progression is 3. So that is how we do it. Remember to subscribe to this channel and share the link with your friends. We're going to answer another question, still in paper 2 session 1, whereby the question now is talking of matrices, and we are told the matrix M, which is equal to 3, negative 2, negative 5y maps a triangular object of area 7 square units onto 1 with area of 35 square units. Find the value of y. We know very well that the determinant of a matrix of transformation is equal to the area scale factor, which is after the transformation. So we can talk of the area scale factor, which is the ratio of the area of the image to that of the object. Therefore, we have an object whose area is 7 and we are getting an image of area 35. So the area scale factor is 5 in this case. Therefore, the determinant of the transforming matrix must give us area scale factor. This means for us to get the value of y, we can now get into the matrix and find its determinant. Then we equate it with the area scale factor, which is already 5 here. So we can say determinant is equal to area scale factor. And the determinant is calculated by the product of the elements in the leading diagonal minus the product of the elements in the other diagonal, such that when we take 3 multiplied by y, then we subtract negative 5 by negative 2. This one must give us area scale factor, which is 5. So this means 3y minus 10, this one becomes positive, equals to 5. Now we can solve for the value of y by equating 3y with, when 10 is taken to the other side, it becomes a positive. So 10 plus 5 is a 15. And y is going to be 5 when we divide through by 3. So that is how we answer the two questions in this case. Thank you for following. Subscribe and share our link.